Hi everybody. I wanted to give you some basic guidelines for how to study for exam 1. And what you want to do first is just make sure that you have all of your resources available to you printed out so that you can easily study. So for example, for every video that I have posted on Blackboard, I've also included a PDF file that has the different slides. And hopefully you've been printing those off, and as you watch the videos, you fill them in as you go with additional information and notes. Well, that's really what you want to study. Essentially, I'm giving you a study guide for each section of the textbook. So for example, right from the very beginning, we started out with the basic definition of statistics, and from there, we started to introduce a variety of different concepts and terms. You want to make sure that you are familiar with those terms, forward and backward, because we need to be speaking the same language. If I start asking you questions about population parameters, for example, or questions about sample statistics, or if I started asking you what a representative sample was all about and why it's important, if you didn't understand the basic terms, there'd probably be no way that you can answer questions about those terms. So terminology is a pretty important thing. We talked about a variety of different concepts, as I mentioned: sample statistics, descriptive statistics, sampling error, inferential statistics, margin of error, confidence interval. All that was just in the very first section of Chapter 1. So here was just kind of a listing of some of the stuff that was in Chapter 1, Section 1, and I'm just trying to give you a heads up. Make sure you know these terms. If you don't know the basic terms, there's not too much that I can do to help you out. So at the very least, pay attention to the bolded terms. From there, you want to make sure that you understand things on a more conceptual level. So we talked about sampling. Why is sampling important? Well, we covered that. We want to find a representative sample so that we can learn about a population. We talked a lot about different sampling methods. You'd, of course, want to make sure that you can understand each sampling method. And then when I give you an example, you can determine what sampling method was used. What are the pros and cons of each sampling method? We started talking about different types of studies. We made a big distinction between correlational studies, also known as observational studies, and experimental studies, where we have treatment groups and control groups and we compare them. There are important concepts that are associated with these different types of studies, like random assignment. We want to make sure we understand why we use things like random assignment in a true experiment, and why in a true experiment we can prove causation, but in an observational study we cannot. There were 8 guidelines that we discussed for evaluating statistical research studies. Of course, you're going to want to be familiar with them, so that if I ask you why is one of these guidelines important, you could explain to me why it is. Again, there were a lot of concepts that came up in describing our data. We were able to describe our data by referring to it as qualitative or quantitative. If we had quantitative data, we were further able to break it down in terms of discrete or continuous. And we talked about how our data could be described on various measurement scales: nominal, ordinal, interval, or ratio. There's a lot of good information in there. Of course, I'm going to ask you questions about that. You should be able to look at an example and determine how to classify each type of data. We talked about some other terms that went along with measurement in terms of precise measurements, accurate measurements. In the normal world, those things mean essentially the same thing. In the world of statistics, we've learned that they don't. We've learned that there are different types of errors that can be made in measurement, whether they're random or systematic. Of course, you want to be familiar with that. We also talked about quantifying these errors in terms of an absolute level of error or a relative level of error. You want to make sure that you can go through and calculate those types of errors. We talked about those errors a variety of different ways. We talked about absolute and relative errors, absolute and relative differences, and you learned that they were essentially the same thing, just applied to slightly different contexts. So be familiar with them, particularly something like this. We're talking about absolute and relative differences with percentages from a research study. This was a really interesting example, and I just recommend that you're familiar with it. We started going on and talking about how to summarize our data with frequency distribution tables. Of course, you need to understand how to look at these tables and figure out what those tables are trying to tell you. And then from these tables, you should be able to extract information like we did right over here. So for example, from that table, you should be able to compute an average value, a mean. In addition to looking at frequency distribution tables, like we see right here, we looked at frequency distribution graphs. Just like with the frequency distribution tables, you should be able to look at the graph, understand how to interpret it, be able to extract some information from it, and then compute something like a mean, or in this case, a probability, or the proportion of people, in this case, who earned an A. We also talked about some other ways to simplify and summarize our data, like using a stem plot. So, just like I said before, we want to make sure that we understand the basic stem plot. We want to make sure that we can extract information from it and then compute something like a mean. We talked about some perceptual distortions. You want to make sure you can tell that story. You know, what is the story being told here? What's the problem? Why are we saying that this is distorted and it's not fair? We started talking about some basic measurements of our data using quantitative methods. We talked about using things like the mean, the median, and the mode to describe central tendency. And you can see it's pretty easy to compute these things, the mean, the median, and the mode, but there's lots of other information associated with it. So we want to make sure when we're talking about central tendency, we can discuss the pros and the cons of each of these three measures, and we can understand their properties. We talked about shapes of distributions. You should be able to look at a distribution and describe its shape. One way that we described its shape was in terms of the number of peaks, but of course we also described shape in terms of being symmetrical or skewed. You should understand how to discuss the shapes of our data, the shapes of the distribution, and then also understand how the mean, the median, and the mode react to the different shapes, specifically with a left or a negative skew, or a right or a positive skew. We talked also about how to take our data and measure how much variability there is in the data. Specifically, we computed some basic things like the range. Of course, you'd want to be able to compute the range. And then we also talked about measuring variability using techniques like the 5-number summary. And then we were able to use the values from the 5-number summary to create a visual way of looking at variability with a box plot. And then finally, one of the things that we computed was the standard deviation. Now this took a little bit of work. We used summation notation, but keep this in mind, people. All that I can do is give you different numbers. The formulas are always the same. You should be able to come into the exam and nail this. All I can do is give you different numbers. You already know it's going to be on the exam. You should be able to come in 100% prepared for something like this. And then, of course, there will be conceptual questions about these things that we compute. So, for example, when we look at the formula for computing the sample standard deviation, we're not simply computing an average of the squared deviation scores. We're computing kind of a modified average, and I discussed why that was the case. So, conceptually, you're going to want to understand why we're doing the things that we're doing and be able to answer some basic questions about it. Finally, we talked about some interesting paradoxes when it comes to statistical information, and I went through an example where there were false positives and false negatives for a medical test, and we were able to compute then what's the probability that somebody actually has cancer given that they have a positive test result. And we found that that value is really kind of low, lower than you might expect given some of the information that we had. You should make sure that you understand this and be sure that you could reproduce the values in this matrix to compute basic probabilities like we discussed in the video. That's about it. I hope that this will help you focus your studies. Everything that is on the exam is something that we have done in the lectures online. Much of that stuff we have then focused on in class and went through some examples. So there really should be no surprises. You just need to make sure that you study hard. If you have any questions, just let me know. So good luck on exam 1. For now, that is all.